The mountains of Switzerland recently bore witness to a dramatic and unsettling event. A massive section of the Birch Glacier, a once formidable river of ice, suddenly broke away. This was not a gentle calving. It was a catastrophic collapse, a thunderous roar echoing through the alpine valleys. The ice, burdened by an immense rockfall, succumbed to gravity and the relentless thaw. Millions of cubic meters of rock and ice cascaded downwards, carving a path of destruction. The village of Blatten, nestled in the valley below, found itself directly in the path of this glacial outburst. Fortunately, due to timely warnings and evacuations, mass casualties were averted. This fortunate outcome, however, does not diminish the severity of the incident. Scientists studying the Birch Glacier noted the complex interplay of factors leading to the collapse. Significant rockfalls, likely exacerbated by thawing permafrost, added immense weight to the glacier. The Birch Glacier incident is more than just a news story from a distant alpine region. It is a microcosm of a global phenomenon. The rapid melting of glaciers worldwide is a stark reminder of the accelerating impacts of climate change. As scientists and policymakers grapple with these changes, the Birch Glacier serves as a poignant example of the urgent need for action. In response to the escalating crisis of melting ice, a dedicated team of scientists has developed a vital new tool. Professors Simini Hao and Dominic Boyer from Rice University spearheaded the creation of the Global Glacier Casualty List. This is not merely a collection of data, it is an interactive map designed to document and publicize the plight of glaciers worldwide. The map aims to bring the abstract concept of glacier loss into sharp, undeniable focus for a global audience. Glaciers are listed as critically endangered, almost disappeared, or disappeared. This classification system transforms scientific assessments into a clear, understandable narrative of loss. The importance of this interactive map cannot be overstated. It challenges the common misconception that glaciers are confined to the remote polar regions. The statistics surrounding global glacier loss are staggering. Glaciers around the world are retreating at an unprecedented pace. They are collectively shedding an average of 273 billion tons of water every single year. This isn't just a slow melt, it's a deluge, with profound implications for sea levels and freshwater availability. The projections for the future, should current climate policies remain unchanged, are even more alarming. Over 3/4 of the global glacier mass is expected to disappear. This isn't a distant hypothetical scenario, it's a trajectory we are currently on. The speed and scale of this projected disappearance demand immediate and substantial action. We are witnessing a planetary transformation in fast forward. The Global Glacier Casualty List serves as a somber archive chronicling the demise of glaciers that once defined their landscapes. One such casualty is the Sérène Glacier in France, which officially disappeared in 2023. In the 1980s, this alpine glacier boasted ice up to 260 feet thick. However, the relentless rise in global temperatures took its toll. Across the globe in New Zealand, the Bowman Glacier met a similar fate, declared disappeared in 2020. Its decline was meticulously documented, showing a steady and then accelerating shrinkage. The United States has also witnessed the complete loss of significant glaciers. The Anderson Glacier, located in Washington State's Olympic Mountains, was declared disappeared in 2016. These are not isolated incidents, but part of a growing list of lost natural landmarks. Each disappeared glacier represents a disruption to local hydrology and a loss of unique habitat. Glaciers are far more than just picturesque expanses of ice. They are fundamental components of the Earth's systems. One of their most vital functions is as natural reflectors of solar radiation. Their vast white surfaces act like giant mirrors, bouncing a significant portion of the sun's rays back into space. This phenomenon, known as the albedo effect, helps to keep the planet cooler. Beyond their role in temperature regulation, glaciers are indispensable freshwater reservoirs. They store vast quantities of frozen water, accumulated over centuries or even millennia. This stored water is gradually released as meltwater, especially during warmer, drier seasons. The decline of these frozen water towers poses a direct threat to water security for a significant portion of the global population. The importance of glaciers also extends to the very shape of our world and the ecosystems they support. Glacial meltwater sustains unique alpine and downstream ecosystems, supporting specialized flora and fauna. The primary driver behind the alarming rate of global glacier melt is the sustained rise in global temperatures, a direct consequence of human-induced climate change. This phenomenon has been accelerating over the past century, with each decade witnessing progressively higher average temperatures. The burning of fossil fuels since the Industrial Revolution has released vast quantities of greenhouse gases into the atmosphere. These emissions come from various sources, including power plants, vehicles, and industrial processes, all contributing to the thickening blanket of gases enveloping our planet. These gases trap heat, leading to a gradual but relentless warming of the planet's climate system. This warming effect is not uniform, with some regions experiencing more intense heat waves and prolonged warm periods. Glaciers, being highly sensitive to temperature fluctuations, are among the most visible and immediate casualties of this warming trend. The cracks and breaks in glaciers are stark reminders of the ongoing changes in our environment. Higher average air temperatures lead to increased surface melt during the summer months. This seasonal melting is becoming more pronounced, with glaciers losing significant mass each year. Furthermore, warmer winters mean that more precipitation falls as rain rather than snow, even at higher altitudes. This shift from snow to rain reduces the accumulation of snowpack, which is crucial for glacier health. Another significant factor contributing to glacier instability is the thawing of permafrost. Permafrost, which has remained frozen for thousands of years, is now beginning to melt, releasing stored carbon and further exacerbating climate change. As global temperatures rise, these perennially frozen layers are beginning to thaw. This thawing process is not only a sign of warming but also a contributor to further warming, creating a feedback loop. This thawing can destabilize entire mountainsides, as the ice that once acted as a cement binding rocks and soil together melts away. The resulting landslides and rockfalls pose significant risks to both natural landscapes and human settlements. The recent Birch Glacier collapse was partly attributed to rockfalls from areas experiencing permafrost degradation. Such events highlight the interconnectedness of various climate change impacts. As glaciers shrink, they expose darker underlying rock or soil, leading to localized warming. This exposure accelerates the melting process, as darker surfaces absorb more heat compared to reflective ice. This is known as the ice albedo feedback. The more ice that melts, the more heat is absorbed, leading to even more melting, a vicious cycle that underscores the urgency of addressing climate change. The consequences of widespread glacier loss extend far beyond the immediate mountain environments. One of the most widely recognized impacts is sea level rise. The melting of land-based ice, such as mountain glaciers and the massive ice sheets of Greenland and Antarctica, adds vast quantities of water to the oceans. This contribution is a significant driver of the observed rise in global sea levels. Downstream from melting glaciers, the initial surge in meltwater might temporarily boost water availability, but this is a deceptive and short-lived phenomenon. As glaciers continue to shrink and eventually disappear, the reliable summer and dry season meltwater they once provided dwindles, leading to severe water scarcity in many regions. The ecological ramifications of glacier loss are profound and multifaceted. The Himalayan mountain range, often referred to as the Third Pole due to its vast ice reserves, faces a particularly acute crisis from glacier melt. These glaciers are the headwaters for many of Asia's largest and most important rivers. The seasonal meltwater from these water towers is critical for drinking water, agriculture, and industry across a vast and densely populated continent. Monitoring these crucial ice bodies in the Himalayas and other Asian mountain ranges presents significant challenges. Many of these glaciers are located in remote, high-altitude, and politically sensitive border regions, making access for scientific research difficult and expensive. The consequences of inaction in the face of this melting are already being felt. The evidence is undeniable. Glaciers across the globe are not just retreating, they are disappearing at an alarming rate. This phenomenon is not confined to one region, but is a global crisis affecting every continent. The recent collapse of the Birch Glacier in Switzerland is a stark reminder of the fragility of these ice giants. The documented vanishing of the Seren, Baumann, and Anderson glaciers further underscores the urgency of the situation. And the critically endangered status of Nepal's Yala Glacier are not isolated anecdotes, but chapters in a rapidly unfolding global tragedy. These glaciers are vital indicators of climate health. The Global Glacier Casualty List serves as both a grim ledger and an essential educational tool, highlighting the widespread impact of climate change. It highlights the vulnerability of glaciers in tropical latitudes, such as the Santa Isabel Glacier in Colombia, which are melting at unprecedented rates. The loss of these ice bodies signifies much more than a change in scenery. It means diminished freshwater supplies for billions, affecting agriculture, drinking water, and ecosystems. The urgency of this situation cannot be overstated. Immediate and decisive action is required to mitigate these effects. We are witnessing in real time the dismantling of critical components of our planet's life support systems. This is not just an environmental issue, but a humanitarian one. The projection that over 3/4 of global glacier mass could disappear under current climate policies is a terrifying prospect. This would have irreversible consequences for our planet. The time for incremental changes and hesitant policies has long passed. We need bold, transformative action now. The fate of the world's remaining ice, and by extension our own, rests on the choices we make today. Our actions will determine the legacy